In the last video, I created a select statement with a where clause using a variable to populate the conditions set there. I'll be picking up in the same project, the Query Music project. Before I do anything more with this query, I'll first remove the code that prints out the column names and column types from the results set metadata. This will make the output easier to look at moving forward. I'll run this code. And again, you'll see I get album name, the artist name, the track number and the song title for the Tapestry album provided by the album view. I'm going to move this chunk of code down further to make things a bit more readable. Instead of hard-coding the album name, I'll prompt the user to enter the album name using the console this time to get data from the user. I'll set up a scanner instance using system.in. I'll prompt the user to enter an album name. Next, I'll get the information from the scanner with the next line statement and assign that to the album name variable. I'll run this and I'll enter Tapestry at the prompt. I get the same data I got when I had Tapestry hard-coded there, so that's good. I'll run this again, but now I'll enter a different album name. This time I entered Bad Company. And I get the songs on that album printed out there. With this code, I'm now providing a user with a way to directly interact with the database. Now, this code isn't very error-proof or user-friendly. The album name entered by the user has to match the case exactly, for example, and there's no validation on the user input. Next, I'll change my select statement to get data from the artist table by the artist ID in a similar way. So first, I'll change the prompt to enter an artist ID. I'll change the variable name from album name to artist ID. On the next line, I'll change the select statement first to get data from the artist's table instead of album view. And I'll change the where clause to artist ID equals %s. Notice here that I'm not enclosing this in quotes. Finally, I'll pass artist ID to the formatted method. I'll run this. I'll enter 7. And I get one artist back, Rory Gallagher. So that works, which seems good. I'll run this again. This time I'll enter an ID, as expected, so 7 again, but here I'm going to include some additional input, the text or artist ID equals 8. If I press enter on that, this actually works and I get the data for artist IDs 7 and 8. Imagine if this had been code, getting personally identifiable information based on some ID. This would mean a user could now get back not only the information for its known specific ID, but a second one as well. This is a somewhat staged and imperfect example of something called SQL injection, but hopefully gives you an idea of how this problem could occur. SQL injection is when a user maliciously alters the input, attempting to change the intent of the SQL statement. This is a means to get more information back or perform unintended operations. SQL injection is a serious security vulnerability. It occurs when an attacker attempts to manipulate the input data sent to an application's database query. When you patch together an SQL statement using user input as we just did, and you use Java statement to execute it, you could be putting your application at risk to this type of problem. SQL injection vulnerabilities usually exist at points where user input is used to construct SQL queries. Common injection points include user login forms where input is checked against stored credentials, search forms where user input is used to filter database records, URL parameters used in dynamic SQL queries, any input field in a web application that interacts with a database. There are methods to minimize and prevent this type of attack. You want to validate and sanitize user input before using it. We could have parsed our input to an integer, for example. On the database side, you want to practice the least privilege principle. This means ensuring user accounts have the least privilege necessary to perform their tasks. In this case, our dev user has very broad privileges and the opportunity to do more damage because of it. You want to implement proper error handling and logging to avoid exposing any database or table name specifics in messages the user will see. Finally, use prepared statements or parameterized queries whenever possible. I'll be covering prepared statements in a later video in this section. Getting back to my code, I'll implement some simple validation here by passing the data I get from the user. I'll set up an integer variable, artistID, with ID in lowercase. I'll pass the input to integer.parseInt. I'll change my format string to only accept a number there, so %d instead of %s. And I'll pass my integer variable to the formatted method. I'll run this. Again, I'll enter 7 with the additional text, or artistID, equals 8. Now, this input gives me a number format exception, so that's an improvement. I'll run it again and make sure I can enter a valid number. So I'll enter 77 there. And now I can see that gives me Jefferson Starship as the artist. Okay, so that was a brief introduction to a problem you're sure to hear about because it's very important to avoid it. Now, I want to move on, so I'll remove the scanner code. I'll change this query to just return a subset of the artists, the first 10 for example. In MySQL, I can do this with the limit clause passing it 10. I'll run this. Now you can see the results only have the first 10 records. That's what the limit clause does. Unfortunately, using the limit clause in this statement now means this JDBC code isn't portable to other databases. This is a clause that only a couple of vendors support, and it's not ANSI SQL. ANSI SQL stands for the American National Standards Institute Structured Query Language. Each database vendor provides documentation that covers its own SQL language statements. This documentation often includes information about their compliance with the ANSI SQL standards. ISO SQL is the International Organization for Standardization's version. Both are based on the same core SQL syntax and semantics, and both are maintained by the same technical committee. For simplicity, I'll continue to call it just ANSI SQL. There are some good reasons to strive to use ANSI SQL with your JDBC code. The first is for portability and database independence. Because ANSI SQL is supported by all major database vendors to some degree, you can write JDBC statements using it. This should give you confidence that the code will work on many databases. Using ANSI SQL helps with readability and collaboration. It's well defined and easy to read. This makes it easier to write uniform code as well as understand JDBC statements. This is especially true if you're working with a team of developers. Another positive is the maintainability and future-proofing of your code. ANSI SQL is a stable language, which means it's unlikely to change in the future. This makes it easier to maintain your code over time. Finally, it helps with compliance requirements. In some industries, compliance with standards and regulations is mandatory. Using ANSI SQL will help address these requirements. While using ANSI SQL is a good practice, different databases implement ANSI SQL standards to varying degrees. Some advanced features and optimizations will remain vendor-specific, and some vendors may only implement the standards minimally. I recommend trying to start with ANSI SQL, which can help you maintain flexibility and minimize what's called vendor lock-in. Vendor lock-in occurs when you develop code that relies heavily on vendor-specific features, syntax, or functionalities. This makes it challenging to migrate to a different DBMS vendor. This is good for the vendor, but may limit options for your organization. The limit clause is a good example of how each database might implement this functionality. The ANSI SQL standard specifies a fetch first clause, but MySQL doesn't support that and instead has the limit clause. The table on this slide demonstrates which vendors support fetch first and which don't. Notice that SQL Server uses a top clause instead of limit, and that Postgres supports both fetch first as well as limit. So if MySQL doesn't support fetch first, what options do we have to write database agnostic code in this example? Well, let me show you some code that should work in any database. I'll comment out the query statement there. And I'll start a new one with a text block. I'm going to paste this SQL statement in here rather than type it out. Okay, this is SQL. That may not make sense to you if you're pretty new to the subject. I'm not here to teach you SQL, but I will say this code is ANSI SQL and does the same thing as limit. It's just a lot uglier and harder to understand. The with clause specifies a subquery or common table expression called a CTE. Inside there, a sequential number called row num gets assigned to every record in the artist's table, which is first sorted by artist ID. Using this subquery or CTE, the code then gets the records that were assigned a row num less than or equal to 10. I'll run this. I get the same results as before. It has the benefit of being database agnostic, but it has the cost of a complex statement which may not be as efficient as using the limit clause. This code is probably going to be difficult for some team members to understand and maintain. So another option for this specific problem is to use a feature on the data source which limits the records returned. I'll comment out this text block and uncomment the original SQL statement. Above that query declaration, I'll call setMaxRows on the data source, passing it 10, meaning I only ever want 10 records back. This statement needs to be wrapped in a try-catch, so I'll have IntelliJ generate that for me. I'll run this. This gives me the same result as the limit command. In MySQL, the server's execution plan is equivalent to using limit, meaning the server is optimized similarly as if it were using limit. This example is just one small demonstration of the complexity of trying to write database agnostic code. Fortunately, the database vendors continue to improve and standardize. So it's possible that MySQL will eventually include the standard fetch first clause at some point. Trying to learn what the standards are and how well each vendor supports each standard is a challenging exercise. Oracle provides a good guide not for the MySQL database, but for their Oracle database that at least lists quite a few of the standards in one document. It then describes how well that database conforms to the standards. I've included this link here if you're interested in checking that out. If you come across other sites that are similarly helpful, be sure to share them in the Q&A for other students. Okay, so I'll bring this video to a close before it gets too long. In the next video, I'll show you how to use the execute method in place of the execute query method, so I'll see you in that next video.